Hi and welcome back to this follow-up video of the low ohmic resistance tester. Basically just to round the project off, I found this box. It's not a particularly expensive box or anything. It's a nice blue colour, but you know, it's just plastic. And I'm thinking it fits very well if you just sort of like place it in there. And I'm thinking that should be pretty good. By the time that's flush with the top, we've got quite a bit of gap underneath for other things, and I've got an idea for that space, but really this will go onto the lid like that. And of course the cool thing with these transparent boxes is you can see through them a little bit, which makes them very easy to drill out where the mounting holes are. Once you're happy you've got everything positioned where you want it, just put a little black mark on there and it makes it very easy to work with. That'll be bolted to the top like that. That'll just like sit in there. This knob's completely wrong. We need a thinner one with a longer shaft on it, and we'll want that to protrude through the box so you can turn it from here. I'm gonna have to find something more suitable. Have a bit look around for that. That's the idea of it. That whole thing will go in there, and we've got plenty of space. We've got a gap down here, we've got a gap underneath, and we don't want this case to be like ridiculously big. You know, it's quite a simple project really. We don't want it to take up too much of a footprint on the bench, but yeah, maybe an aluminium version would be better than this transparent blue. Just makes it stronger. These are quite bendy, they're just thin plastic. Can't see it lasting very long, especially if it's next to a soldering iron. It's probably going to get burnt at some point. Power wise, I'm thinking why don't we use something like one of these. This is a USB with a USB chip on there, which gives us TTL levels. We can use this to supply the 5 volts. In other words, plug this into a computer through a USB cable or into a 5 volt wall adapter, which are very easy to get hold of. Either way, you can plug that in and that will allow us to get power at this side, which has just taken the power from the USB socket. But we can also connect up the RX-TX lines of the USB through this interface chip here and connect those to our serial COM connections on the board. Aha! So this might come in handy after all. By making a firmware update, making a firmware change, we can send data to this and read data from it using the serial library within the Arduino IDE. And that will allow us to connect through this, connect to a computer, so we can do data logging or remote access. We can maybe set the set point automatically remotely. We can take readings, like automated readings from the computer, whatever we want. So it's going to serve two purposes. It kind of solves a lot of things in one go, and it may give us serial comms at the same time through USB, through a COM port. And so I'm thinking maybe fit that into the box. I've also got a couple of these 4mm banana sockets in different colors, and of course we really want red black, which is what you normally have on test meters, but I've got some other colored ones as well. You can plug straight into those. These are going to be for our probes. So what I'm thinking is that this is the rough idea. A couple of these on the front, something like that, so you can plug in. Maybe the USB socket on the front, just so everything goes in the front, but not very neat. You're going to have a cutout hole. So I'm thinking maybe put the USB on the back, or on the side rather. That's the back. Put it on the side, so the USB would actually fit inside of there like that. Maybe it's in the bottom, and have a little cutout hole at the back there, just so you can plug your cable in. Maybe raise it up a little bit, put it on some sort of a little platform. So that's the general idea, and as I say, everything seems to fit very nicely. This is a standard size project case, very cheap, like £3 or £4 or something. It's a Hammond, inspected by Jeff 101. Hello Jeff, from Hammond. So standard box, but question is, do we want to go aluminium, exactly the same size, same dimensions, just in a die-cast aluminium box, and then we could spray the thing black or whatever color we like, make it look a bit neater, you know, rather than just aluminium, or we'll just go for this cheap plastic box. I'm tempted just to do it this way because it's going to be nice and quick, and I kind of like the see-through plastic idea. Don't forget we're going LED as well, and what I'm thinking is, because this is a see-through box, we could just like mount it inside, pointing up like that, you know, somewhere inside. And this thing is so bright, the whole lid is going to light up. You know, you're going to get like a whole illuminated area around here, sort of lighting up blue because of the plastic. By the time you get the display in, and you get the LED there, and you got the two terminals, and you got the USB socket on the back. Stick some rubber feet on the bottom. I don't have any. Yes, I have. I've got some feet. I've got a drawer full of sticky feet. We can put some sticky feet on the bottom. That's where we are, and let's maybe give it a go. I think I am going to go to use the plastic one. It's just going to be quicker for the purposes of the video. Maybe later on we'll rehouse it and put it in an aluminium box. Who knows? Right, let's go. I'm mounting the display onto the front panel, and as you can see, we've used a few standoffs. Had to adjust it a little bit. A couple of packing washers in there just to get the height exactly right, so it's completely flush on the inside to the top of the front panel. And I was just looking at this, and I thought, you know, we've actually got a transparent front here. Wouldn't it be lovely if we didn't actually have to cut out a hole? I don't know how far this is going to get, so I've got like a little regulator here just to give us a quick 5 volts test. Let's have a look. Well, it's kind of fuzzy. Yeah, but you can read it. It's just not very clear. To be honest, it looks better on camera than it does in real life looking at the front. It looks a bit hazy. It means that it would have been actually quite stylish. We could have not had a hole there. And I suppose it's usable, but it doesn't look very good. But the cool thing is it's completely flush. With it being a blue LCD backlit display and a blue box lid, the whole thing kind of works. Anyway, that's done, so now we're going to do a cutout and also the hole for the encoder wheel, which is hiding inside of there. Okay, let's keep going. Okay, so we're busting out the milling machine here. It's all manual and a bit customized. Change the threaded bar so it can get higher. I've got double adjustments so we can go further around. So yeah, haven't used this for quite some time actually, so I hope this doesn't completely write the entire box off. Let's see if we can cut out the LCD hole here. Let's give it a go. Could be a bit noisy. It's that long since I've used this thing. Okay. See where we are. Okay, we're in. It's messy. I think I need my vacuum cleaner on this. Yeah, I'm going to do that. Getting a lot of dust. I'm going to put the vacuum on. Got the vacuum cleaner connected there, so hopefully this should get rid of a lot of the dust. So it's going to get pretty noisy in here. Let's go. Vacuum on. Okay, that's better. Yeah, it's a lot better. Okay, we're getting to the end. That's it. Yeah. Well, it looks okay, but I don't know if everything's going to line up when we get the displayer in. So let me just hoover up and clean up, and we'll check out to see if the display actually fits. Right, okay, so bench clean up, and here's our lid. I'm just going to give this a bit of a wipe, and it looks okay. I haven't completely destroyed the box, but I haven't checked the alignment yet. Just get rid of some of those edges. It gets a bit messy with plastic. It's better with aluminium or something like that, something a bit more solid. Right, that's cleaned up nicely. So where's our display module? Where is he? There he is. So I guess we need to align this up to the holes, and you're seeing this with me. I believe that's lined up. It's pretty good. It's pretty good. That's pretty close. There is a slight alignment error, but actually it's bang on really. Do you know what? Yeah, I think we're pretty good. Okay, I'm going to put this, going to finish these other holes. Now the other thing so that was a success. Nice one. So these are going to be the terminals. I've decided to put the probes on this side because we've got a nice big gap here and there's nothing going on behind the box or anything. I thought, well, I originally wanted to put them on this side, and there's a bit of a problem because the knob itself may actually end up being a little bit bigger, and it may get a bit fiddly and a bit close to the terminal. So I'm thinking, you know what, leave that alone, so you can have any knob size you want on there. You can have a big one if you want. Let's just leave that alone so you can get to it, and I'm going to put the terminals on this side instead. So that's what we're going to do. All right, so there you have it. Got the module in. Looks pretty tidy. I think it looks tidy anyway. The probe's in, except I've just realised I've put them round the wrong way. I want the red on the top. I'll swap them round later. Doesn't really matter. I like to have positive on the top, negative on the bottom, but whatever. That's the hole for the data wheel. I don't actually have a suitable knob, the one I was using. It doesn't have an actual collar that sticks out. You can get knobs which have like a sort of a collar that comes out like that, and that's the kind I want, and it'll go into the hole there. I may have to adjust the size of the hole just to get the thing to fit. We'll cross that bridge when we get to it. You know, I'm not too worried about that, but we'll find something that will go into there. But the main thing is, there's all the holes in, and the module's in. Now, let's light it up and see what it looks like. Yeah, okay. Yeah, and I've turned those terminals around the correct way as well. Ha. Okay, let's light this up with some 5 volt with a little thrown together regulator. Just see what it looks like. Well, it's a hell of a lot sharper. I think that looks pretty good. We've got a slight black edge down the left hand side, but you know what? It doesn't affect anything at all. And I guess if I slacken off the screws, I might even be able to just jiggle it. It's not even a millimetre, it's half a millimetre edge down the side there. It's a fraction. And I reckon it doesn't even matter. I mean, you can read all of the characters, that's the main thing. We're not losing anything, and it looks pretty neat. That's it. I mean, it's looking pretty good. I'll just reset it again. Put the power on again. There you go. I'm just running off a 9 volt battery with a 5 volt regulator at the moment, 7805, with some croc clips thrown together just to get some power on. Yeah, it looks pretty good. You can see a slight border, but it's nothing. Not even bothered about that. And I think what we need to think about now is, apart from maybe have a bit rake around on eBay or something to see if we can find a suitable data knob. And I may have to make the hole a little bit bigger depending on the knob that we end up with. I didn't want to make the hole too big just yet. So yeah, the next thing to do is to probably get the USB power module. Well, I'll say power, as I mentioned before, it's actually an RS-232 or a USB serial device, a TTL compatible in and out. That can go to our serial connection here. I guess in hindsight, looking at it now, this would have been good on the PCB, design it in and make the thing USB from the very beginning. You know, it's a prototype and we're sort of making things up as we go along. I might just put it in the bottom of the box itself maybe, so we can access it through the back of the case or something like that. But yeah, I'll have a think about that. But that's where we are, and I think the getting the power on is the next step. Had a bit think about it, and yes, we could just put it in the bottom like I said and stick that in, you know, in the bottom of the case. Yeah, that would be fine with some wires coming off it. Haha, but had another thought. How about this? Had a bit look around the PCB. There is, just purely by accident, a space just in here next to the connector where the board isn't going to hit any contacts or anything inside. There's a little 3-pin header on there. Hardwire that and take off this connector so it goes quite flush. But that will sit inside of there like that. Okay, maybe it's just put it on a sticky fixer or something like that, just to hold it in place. If we get that located correctly, when that goes in the box, it'll slide down here, and if we get the alignment somewhere near correct, when that goes down into there like that, there's the USB socket just there. Then we can mark that out with our black marker pen and make a hole, rectangular hole, so the USB plug can plug straight in. So yeah, so it means that you can lift it out in one lump like that. It's getting quite compact now, and this would have been excellent on the original design. But of course, at the time when we're designing it, I didn't really have too much of an idea how we're going to power the thing. I thought maybe it's a battery and a DC converter or a regulator, or just some sort of external supply plugged in. But this is much needed because, as I've already mentioned, it means we've got serial comms, and those serial lines can go straight to the serial header there, just there. That's what I'm going to do. It means taking this apart, we can fix this board inside and wire it in. So this is the idea. I've detached the display from the board. Now you can see why it's a good idea to have these things on connectors, because that would have been a real pain to actually remove that. And with the connector, it's easy. And that's allowing us to get inside, and we can actually put this more or less there. That's what I'm thinking. Probably want to get this distance here correct, or somewhere near, so it's near the wall of the case. Okay, so the plug doesn't have to go too far in. You can always make the hole bigger. If you need to get the whole plug in, you could do that, just make a bigger hole. As long as it goes in and connects to this, which is just a micro USB connector. Okay, right, check this out. So take the box away, and there's our module stuck in there. So it basically lines up with the wall of the case, with the bottom side of the box, and pretty much touches it, which means when we drill the hole in the side, it'll go straight into the plug. Those two connections there are the serial comms pins, on the back side of the board, and this can come straight from here straight to that. So the connection is very short, and the other two is the positive and the ground, and that can go straight to here as well. So we don't even need to have anything connected. Take this off. Don't even need anything connected to there for this particular design. All right, so there we are. The USB board is actually stuck in there, and I've gone ahead and made a little connector, a little DuPont connector with some wires. I've tapped the 5 volts straight into the 5 volt connector, so when we get 5 volts from the USB, just go straight to there. And I've also got the TX/RX lines here, which will go to these two pins here, except I haven't quite figured out which way around they need to go. So I'm going to power it up first, do some measurements and see which way around. Don't want to get them round the wrong way. Okay, let's put the whole thing back together again. I've got a little wall adapter which gives us 5 volts USB out. I'm going to plug that in, and let's just see if the whole thing powers up. Or will it release the magic smoke, as they say? Hey! Oh wow, it's got an LED in there as well. How about that, man? How about that? First time. So this is now being completely powered up by the USB. It's got a nice little LED on there as well. I didn't realise that on the back. That looked nice in the box. More pretty lights to look at. So what I need to figure out now is the TX-RX lines and get them around the right way. Don't forget there's nothing actually in our firmware yet which takes advantage of the serial COM port. Once it's wired, you don't have to worry about it. Then it just becomes a firmware problem, and we can use it for any purpose we like. Even if it just says hello world when you switch it on, whatever. But it would be nice to, you know, put some actual functionality in there, reading numbers and setting the set point and what have you. Oh, looking good. Have to say, I'm quite happy so far. Just happy accident really that we had the space on the board to be able to stick that in there. You know, if the board had been a lot more dense, we probably couldn't have done that. But we've got plenty of space, and that board just fits in quite nicely. But the good thing is now it's all fixed into position. When you put that into the box, we can see exactly, can you see that? You can see exactly where our hole needs to be for the plug. Perfect. I like these transparent boxes for that very purpose. It makes, you know, drilling holes in places a lot more accurate. Okay, so we've got the serial wires wired in. As I say, we don't really need to use the 2-pin headers anymore, or the power terminals, because it's all wired on the back. And we've also got our 2 probe wires here. I may put some small value capacitor across here just to stop interference. If there's any RF around or anything, it may actually you know, cause a problem. So I'm thinking I might just put like some sort of protection across here, possibly back-to-back diodes or something like that to stop over voltage. But it could be done exactly just here, right across the terminals. So that's a possibility. And what I need to do is to wire this into the board. So let's just negative probe goes in there, positive probe goes in there. Give those a little nip up, and that's how our probe's connected into there. Okay, and there's a little bit of twisted wire there just to connect them together. So, and let's put the power on, and we should hear bleeps and display and all kinds of things. So let's try that. Okay. Yep, that worked. The thing here is we should actually be operational. So I'm just going to plug in a couple of proper probes finally, instead of using dodgy bits of wire. Okay, it's set to 0.5 of an ohm. We should get a bleep. Yep. Ah, the ohms resistance says it's 2 ohms. Have I got a dodgy lead? Right, well, there's a problem. I'm going to have to figure that out. Yes, indeed. I've got a faulty probe. So that doesn't work. This is funny because it's actually our low ohmic tester is testing my probes, and it's telling me that I've got a faulty probe or probes, because I'm getting like 2 ohms. Do you see that? About 2.6, and it's over the alarm limit, so it's just not bleeping. However, if I turn this around a little bit and you look at the sides where the terminal posts are, if I take the negative terminal and go straight to the positive, it works. If I take the positive and go to the negative, it doesn't work. So that's telling us that this positive probe is faulty. Hey, we've diagnosed our first problem using the low ohmic tester. I've got a faulty probe. Oh, hey. So let's pull him out. I've probably got a bad wire or something. I don't know. Let me find some more probes. Yeah, and I found the fault. Problem with the probe, the end plug totally like pulled out and frayed, so I'm going to resolder. I've actually got a new end plug for that, sort that out. So it actually told us there was a problem with the probes. I didn't even know. I was going to mention, while I was putting these probe sockets in, there is a, let's say, a standard for the distance between the probes. It's about 19 millimeters or 3/4 of an inch. And if you keep the probe sockets at that standard distance, it means you can get double connectors like these and various shunt adapters and that kind of thing that have two plugs in one. You see them, you know, they get used for quite a few things, and if you get the distance right, well, it accepts them, so you can plug straight in just like that. So we have it in a box, and what I've done is I've put a little cut out hole in the back so we can get the USB plug in. It's a little bit rough at the moment, I might have to tidy that up, and I haven't got the screws in the lid yet. You might notice we've found a knob which you can also push down. That's the correct collar height. It goes inside of there. Perfect. Found it in my junk box. I've just thrown the speaker inside the bottom. It kind of fits. It's not very good. So obviously there's a little bit of tidying up to do. But the speaker is in the base. So let's give it some power and light this thing up. Be nice if it had some kind of a stand on the back, so when we're using it we can actually tilt it like this. I've temporarily repaired one of my broken probes. Did a quick repair on that. The wire had actually given up, so I need new probes. These are just rubbish. I'm going to have to throw them away and buy some new ones, I think. Simple as that. So anyway, let's give this a go. Set point is 0.5 of an ohm. Let's just short them out. Yep. Looking pretty good. Good reaction time, fast enough. So that's reading 0.22 of an ohm, 0.23. We can't actually null anything out yet. That's what this is going to do when you press and release. Very good. So the idea is, if you've got an old PCB board like our G0BZY repeater project, it means we can quickly now go through traces, so that, you know, and we can check tracks. He's good. It's just, yeah, that's the ground, so we can quickly get through 0.28 of an ohm there, which is fine. If I turn the set point down to say 0.4, okay, so that's getting a bit more critical. 0.4. Let's test some traces here. Hope you can see all of this. Yep, he's good. That's good. That's good. Now you'll notice that if I go to the trace, there's parts of the trace like there, and the resistance is like 24 ohms. Did you see that? Or 20 ohms, and it's just because of the oxide layer of the copper track. These copper tracks are not coated with anything. So they will, you know, you get copper oxide forming on the actual copper, which works a bit like an insulator. So sometimes the track will work, and other times, but if you go to the end where the solder blob is, which track am I on? That one. Yeah, 0.25, so he's good. That's the ground plane. That's also the ground plane through there. 0.26, 0.27 of an ohm. Absolutely perfect. Exactly what we wanted. So we're able to check tracks pretty quick, and with the knowledge that you're actually passing some reasonable amount of current through, not just microamps or 1 milliamp or something. As you know, we've got it set to like 10 milliamps, and find those problematic traces which a normal test meter might actually show as okay, because they've usually got a threshold of something like 50 ohms or 30 ohms depending on the meter, and anything below that will give you a bleep, whereas this will only bleep if it's below 0.4 of an ohm at the moment. Possibly even do something with the USB connection, write a Windows application, for instance, to work through the serial comms port, and then we can remotely adjust it and read from it. There's all sorts of things we could do at this point, but I think, and I think I said this last time in part 2, but I'm going to say it again in part 3. I think we've finally finished the project and the video series. I really hope you've enjoyed this, and the whole boxing, you know, the finalization and putting the thing in a box. I hope you agree it actually looks okay. Yeah, it's a bit of a cheap box. It's only a plastic cheap box, but it's serving the purpose. Our control works. We can adjust the set point. Hey, there you go. I hope you've enjoyed this series as much as I have. I've now got a nice little working piece of test equipment for the bench, and if you follow along you could probably build your own. If you watch the entire series, I'll take you through the entire process, and hopefully you can come up with one of your own designs to build your own, or something similar to it anyway. Thanks very much for watching. We'll leave it there, and next video will be something completely different. We're done with this now. Thanks again. Big thumbs up. Don't forget to subscribe. Don't forget to like. Don't forget to comment. Do you like this kind of thing? Thanks again. See you next time. Bye-bye.